Welcome to the course Depreciation, Alternative Investment and Profitability Analysis. This is module 1, Depreciation. In this module today I will cover a new depreciation method, that is sum of the digits method. The sum of the digits method is an arbitrary process for determining depreciation which gives results similar to those obtained by the declining balance method. In this method, larger costs for depreciation are allotted during the early life years than during the later years. This method has the advantage of permitting the asset value to decrease to 0, and we have seen that this was not possible for declining balance method and double declining balance method. So, the asset value decreases to 0 in this method or a given salvage value at the end of the service life. So, this method, sum of the digits method, attains either 0 salvage value or a given salvage value. In the application of the sum of the years digit method, the annual depreciation is based on the number of service life years remaining and the sum of the arithmetic series of numbers from 1 to n, where n represents the total service life. This will be clear, more clear when we will give you the examples. The yearly depreciation factor is the number of useful service life years remaining divided by the sum of the arithmetic series. This factor times the total depreciable value at the start of the service life gives the annual depreciation cost. Now, sum of the digits method, let us introduce this method through an example. Consider the case of a piece of equipment costing 20,000 when new the service life is estimated to be 5 years and the scrap value is 2000, that is salvage value is 2000, the original cost of the equipment is 20,000 and the service life is 5 years. And let us apply sum of the years digit method on this. Our V is 20,000, Vs is 2000, n is equal to 5 years, and we have to apply sum of the years digit method. So, method applied will be sum of the years digits method. Now, we have to find out the arithmetic sum of the series. So, if the n is 5, I will sum up from 1 to n, that is 1 plus 2 plus 3 plus 4 plus 5, and which comes out to be 15. Now, the total depreciable value is equal to rupees 20,000 minus rupees 2000 equal to rupees 18,000. So, now the depreciation cost for first year is equal to this 18,000 taken from here into 5 by 15 comes out to be 6,000. Now, and the book value at the end of first year is equal to rupees 20,000 minus rupees 6,000 equal to rupees 14,000. Now, the depreciation cost for the second year is equal to 18,000 into 4 by 15 is equal to 4,800, and the book value will be the rupees 14,000 minus rupees 4,800 is equal to rupees 9,200. Now, the depreciation for first year will have the multiplier 5 by 15 for n equal to 5, where 1 plus 2 plus 3 plus 4 plus 5 is equal to 15. Depreciation for the second year, 1 will be decreased from here 15. For third year, this is 3 by 15. For fourth year, this is 2 by 15, and for the fifth year, this is 1 by 15. So, this is how the factors will be multiplied. So, for the second year, here we have decreased from 5 to 1, this is 5 minus 1 divided by 15. Okay. Now, depreciation cost for third year is equal to 18,000, this remains constant, into 3 by 15. This comes out to be rupees 3,600. So, book value at the end of third year is equal to rupees 9,200 minus rupees 3,600, it comes out to be rupees 5,600. So, we have already calculated book value at the end of third year and depreciation. So, depreciation cost for 4th year will be equal to rupees 80,000 rupees, that the amount which has to be depreciated, into 4th year it is 2 by 15. This is the 15 which has come from here. And this comes out to be rupees 2,400. So, book value at the end of 4th year will be this rupees 5600 minus 2400, which comes out to be rupees 3200. Now, depreciation cost for 5th year will be 18,000 into 1 by 15, which comes out to be rupees 1200, and book value at the end of 5th year is equal to rupees 5600 minus rupees 1200. No, sorry, this is 3200, not 56. This is 3200 minus 1200 comes to be rupees 2000. So, this 2000 matches with this 2000. That means the method has a capability to reduce to the salvage value. We have seen earlier that declining balance method and the double declining balance method, they do not reduce to the salvage value, and by using this method we can reduce to the salvage value or even 0 salvage value. So, this is the positive part of it. Here also we will see that it reduces, it gives depreciation cost more in the early years and less in the latter years. Now, after knowing this, how the method works, let us see something else. Now, you have seen that I have to calculate depreciation for a year, we can have a formula which is given below. So, you can directly find out depreciation for a particular year A. So, dA is equal to 2 in the brackets n minus a plus 1 divided by n into n plus 1 into V minus Vs. Now, let us take example 1. Now, the example 1, Ramanujam purchased an asset on January 1, 2011 costing rupees 15 lakh. The useful life of the asset is 5 years and salvage value at the end of the 5th year is 2 lakh of rupees. Determine the depreciation amount at the end of 2011, 2012, 2013, 2014 and 2015 using sum of the years digit method. Now, this is example 1. Now, original cost of the asset $15 lakh, salvage value is equal to 2 lakh, service life equal to 5 years. Now, so depreciable amount is equal to rupees 15 lakh minus rupees 2 lakh, which comes to be rupees 13 lakh. Now, if you see the sum of the years digits for n years, that means if I take this, this comes out to be n plus 1 divided by n by 2. And if I do this, this is 5 plus 1 divided by 5 by 2, this comes out to be 15. So, depreciation for 2011 will be 13 lakhs into 5 by 15, which comes out to be 5 into, now what I will do, this is repeating. So, I calculate this. So, this is 86666.667, and if I multiply this, this comes out to be rupees 43333 53s.33. So, my depreciation for 2011 is this. 2011 depreciation charged is 333.33. 2012, 2014, 2015. Now, for depreciation for 2012 is equal to 4 into 86666.667. This comes out to be rupees 34666.67. So, my depreciation for this is 34666.67. Similarly, depreciation for 2013 is equal to 3 into 86666.667, comes out to be rupees 2,60,000. So, it comes out to be 2,60,000. Now, for depreciation for 14 is equal to 2 into 86666.667, comes out to be rupees 173333. 173333. and if we compute depreciation for 2015, this is 1 into 8666.667, this is rupees 8666.67. So 8666.67. Now from here we see that this does not decrease linearly. In the early years the decrease is rapid than the later years. So these are the results we can see here, which I have computed. Now let us the example number 2. Now one thing here we should understand that in the first year the depreciation is maximum. This we should remember, because in one of the problems we have to use this trick. Now the example number 2 tells the purchase price of a equipment is 40,000. After the service life of 10 years its salvage value is 0. Determine depreciation expenses each year for the lifespan of the equipment and the book value. Now here it shows, because in the problem, through this problem I want to show you that you can decrease the salvage value up to 0 using this technique. Now the original cost of equipment or asset is rupees 40,000, salvage value equal to 0, n is equal to 10 years, and we all know the sum of the digit equal to n plus 1 into n by 2. This is 11 into 10 divided by 2, which comes out to be 55. So depreciation of first year equal to 40,000 minus 0 into 10 by 55 comes out to be 10 into 727.2727 comes out to be rupees 7272.73. So what I have done, this is a fixed value, so it has been converted into a fixed value, that is 727.2727. Now book value will be at the end of the first year will be 40,000. Depreciation of this first year 7272.73 is equal to rupees 32,727.27. Now depreciation of second year will be this value 727.2727 into 9, that is 10 minus 1, 9, comes out to be rupees 6545.5. 0.45. So the book value at the end of second year rupees 322727.27 minus 6545.45, which comes out to be rupees 26,181.82. Similarly, we can compute depreciation of third year is equal to 40,000 minus 0 into 8 by 55, that comes out to be 8 into 7 27.2727 comes out to be rupees 5,818.18. So, book value is at the end of third year $26181.82 minus 5818.18, which comes out to be rupees 20,363.64. Similarly, depreciation of fourth year, 7 into 727.2727 comes out to be rupees 5090.91, and book value at the end of fourth year rupees 20,363.64 minus 5090.71 comes out to be rupees 15,272.73. Now, similarly, I can find out for fifth year, sixth year up to the seventh year depreciation of 10th year equal to 727.2727 into 1 comes out to be rupees 727.2727. Now, this is the table which shows the depreciation for the up to the 10th year, and we see that the total depreciation or the cumulative depreciation is 40,000 and the salvage value has decreased up to 0. So, the sum of the DHS method can be applied for 0 salvage value as well as salvage value which are positive. Now, let us see the example 3. In order to make it meaningful to purchase a new equipment, a restriction is put that the annual depreciation cost for the equipment cannot exceed 4,000 rupees. That means, the maximum depreciation which one can charge is 4,000 at any time during the useful life of the equipment. The original cost of the equipment is 50,000 and the salvage value is 0. Determine the useful service life of the equipment if depreciation is charged using sum of the years digit method. Compute depreciation and book values for 1 to 24 years. Now, this has got a trick. I had already told you that the maximum depreciation is in the first year. That means if I can charge maximum depreciation in any year of the surface life, I can charge it in the first year. So, we can take that the first year depreciation in a sum of the years digit method will be 4000 in this case, and if we take this, then it is easier for us to calculate or solve the problem. So, given is original cost is equal to rupees 50,000, salvage value equal to 0, service life n is what? I do not know, it has to be calculated, and the maximum depreciation I can charge, one can charge is rupees 4000. These are the parameters. I had already told that the maximum depreciation can be charged on the first year, because the depreciation charged subsequently are lesser than the first year. Now, we know that if I sum of n digits will be equal to, if it is 1, 2, 3 up to n digits, if I sum it, this is equal to n plus 1 n divided by 2. So, the depreciation for the first year will be 50,000 minus 0, the salvage value, into n divided by n plus 1 n by 2. You can cut these two n's. So, is equal to 50,000 into 2 divided by n plus 1. Now, this can be equated to 4000. That means 4000 is equal to 1 lakh divided by n plus 1, or n plus 1 is equal to 25, or n is equal to 24. So, we have computed the value of n, this comes out to be 24. Now, the things are simple. We have to compute the depreciation from first year to 24th year and tabulate it. So, this will take a lot of time, that is why I have already calculated using Excel, and I will show that to you. Now, this is the table which shows depreciation up to 14th year, and here we will see that in the first year the depreciation cost is 4000, and this shows up to 24th year, and here we see that the accumulation of the depreciation or the cumulative value of the depreciation is 50,000, and the book value at the end of the 24th year is 0. Now, let me summarize. The monetary value of an asset decreases over time due to use of wear and tear and oscillations, and this is obviously this is the cause for charging depreciation. and in this lecture I have demonstrated how to use sum of the digits method of depreciation and have shown you that what are the benefits of the sum of the years digit method vis-a-vis the declining balance method and double declining balance method. Thank you.